So I want to remind you that practice test A is on your Canvas. I would print it and I would do exactly what you did with this one again. But make sure you know why you missed the ones on this one before you do the next one. Okay, so the directions to number 1 say to simplify. So anytime that we've got the directions to simplify, you're going to start breaking these down. Now, one of the things that students are struggling a little bit with on this, and not everybody, just some. Do you remember when we took like the x to the third and we wrote it out like this? Okay, and then we've got the 5x squared and we wrote it out like this. Okay, you would not do that in this situation. And the reason that you would not do that in this situation is because we have pluses and or minus signs. You are adding or subtracting. You only break those down to prime factorization if you've got a monomial divided by a monomial. If you've got addition and subtraction signs, you're breaking them up into binomials, which is the 2 terms, okay? Now, the first thing that we're going to do here is we should notice that there's an x in every single one of those on the top. So the first thing that I'm going to do is I'm going to factor out that x. So I'm going to have x times x squared plus 5x plus 6, okay? And that's my numerator. That's my numerator. And just to keep everything straight, I'm just going to write down my denominator. I'm just going to write it down exactly the way that it is, okay? So I've got x squared plus 7x plus 10. Okay, now I'm going to factor the trinomials, and I'm going to use the sum and the product. Okay, so for my first one, I have a sum of 5, and I got that from this value right here. And I have a product of 6, and I got it from that value right there. Now there's a 1 in front of this, so it's not where I have to break it down even further and multiply the A times the C. This is the more straightforward kind. What happens is students lose that X. When they factor the x squared plus 5x plus 6, they forget to bring down that X. That's what happens with that one. So remember to bring that X down. Then I've got X plus 2 and X plus 3. Okay? Now, I'm going to factor my denominator. My sum for my denominator is 7. My product is 10. So what are the 2 numbers? 5 and 2. Good job. So x plus 5 and x plus 2. Okay? So what cancels? Good. So our answer here, once we've simplified, is x plus 3 over x plus 5. And the number one mistake I get on that one is people forget the x. They have forgotten to bring the x down. Every once in a while, I'll have a student go ahead and distribute that, and they'll give me x squared plus 3x over x plus 5, and that's completely fine. Okay? Either one of those is fine. Okay? Okay. Can I move on to number 2? Okay, here we go. 3 minus x over x squared minus 9. You're probably looking at that 3 minus x and you're thinking, that looks a little weird. Okay, so anytime you see something that looks a little weird, kind of put a star by it, keep it in mind. That I may have to do something with that because it looks a little different than what I'm used to. What are you used to seeing? Instead of 3 minus x, what are you used to seeing? X minus 3. That's what you're used to seeing. Okay? Now, so I'm going to rewrite this as 3 minus x. X squared minus 9 is a difference of perfect squares. So that factors to x plus 3 and x minus 3. That's one of those you've got to be able to identify, and you've got to have that process memorized. So if it's difference of perfect squares, You've got to just be able to look at it and know it. And the way that we look at it and we know it, this is a perfect square. Okay, that's perfect. This is perfect. And what absolutely has to be here? Minus. It must be subtraction. If it's not subtraction, it's not difference of perfect squares. Okay? Now, that 3 minus x and x minus 3 doesn't simplify, but we can make it simplify. Okay? When you see that, what you want to do is you want to factor out a -1. You want to factor out a -1. So if I take -1 out of this 3 minus x, I'm taking a -1 out. -1 times what gives me +3? -1 times what gives me +3? -3. Okay, so this is what happens when I'm factoring out a -1. -1 times what gives me a -x? Good. Okay, so can I rewrite that then as x minus 3? Okay, so here my 3 is positive and my x is negative. I need to be able to cancel with this. I need the 3 to be negative and the x to be positive. That's what factoring out a -1 does, is it switches the order. Okay? That problem is one that students struggle with. Okay? So this, the -1 and the x minus 3. Okay, now what cancels?
X minus 3.
Good. Okay? Now I don't have 1 left in the numerator. I have -1. So my final answer to this is -1 over x plus 3. Okay? Usually if you practice that a couple times, you're good. Okay? Can I go to the next screen? Okay. Now we got a lot more things going on here. But what I want you to do is I want you to look at them one at a time. Look at them one at a time. Okay? So the first one that I'm going to look at is this right here. Okay? And I've got multiplication, so I don't have to keep change flip because it's multiplication. When do I keep change flip? Division. Excellent. Excellent. Okay. So k squared plus 4k plus 4. 4 is my sum and 4 is my product. So what are my two numbers?
K plus 2.
Excellent. K plus 2. K plus 2. 2 times 2 is 4. 2 plus 2 is 4. Okay? Now, I'm going to go to this one. We're going to focus on that one. My sum is 8. My product is 12. Okay? Sum is 8. Product is 12. Put two numbers multiplied together, give us 12. I immediately thought 3 and 4, but what's the problem with 3 and 4? It adds up to 7. I need them to add up to what?
12. So it'll be 6 and 2.
It's 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. Now, if you wanted to, you could go ahead and cancel out that k plus 2 and k plus 2. Okay? I typically don't. I factor everything, then I start canceling things out. But you could. Okay, now I'm going to the k squared plus 6k. Now that looks different. And we're like, ooh, I can't factor that. But yes, we can. What can we do to that?
You would take out a k.
I would take out a k, and that's called factoring out the greatest common factor. Okay, that's what you did, and you're correct. That's exactly what we would do. We just factor out the k. So I've got k times k plus 6. K times k plus 6. So that having a trinomial, and then you throw a binomial in there, sometimes students get confused. But binomials, you can almost always take out a greatest common factor. Okay? Then I've got my bottom one, k squared minus 3k minus 10. So my product is negative 10, and my sum is negative 3. So two numbers, I've got a negative product, so that means one of my numbers has to be negative. What are my numbers?
Negative 5 and 2.
Good. K minus 5 and k plus 2. Now, what you have done there is you have factored 4 different things. Last chapter, that would almost be 4 problems. Okay? So you're having to factor a lot on this test. Okay, now we mark out what's common to both. I have a k plus 2 and a k plus 2. I have a k plus 2 and another k plus 2. I have a k plus 6 and a k plus 6. So I am left with a k and a k minus 5. So my final answer here is k over k plus 5, k minus 5, I'm sorry, k minus 5. Okay? Can I go to the next one? Okay. Now, this one is keep, change, flip. Why is it keep, change, flip? Because of that division sign. You see that division sign? That's when we keep, change, flip. Keep, change, flip. So I'm actually going to write it down. Keep, change, flip. Okay? So I have z squared plus 9z plus 18 over z squared plus 14z plus 48. Change. My division becomes what? Good. And then I flip. So z squared plus 18z plus 80 over z squared plus 3z. Okay? Now we factor. Now students like to try and keep, change, flip, and factor at the same time. I would encourage you not to do that, because when you keep, change, flip, and you factor at the same time, there's just opportunity for mistakes. Typically, students forget to flip when they try to do both at the same time. Okay? So now I've got a sum of 9 and a product of 18. And I wanted it to be 2 times 9, but it's not. It can't be 2 and 9. What's it got to be?
6 and
Good, 6 and 3. So I have z plus 3 and z plus 6. Okay? My denominator, I have a sum of 14, a product of 48. Anybody?
Z plus
8 and 6. Good. Oh, and yep, you're right too. Z plus 8, z plus 6. And again, you see that right there, and you might be tempted to go ahead and cancel it, and you could. I like to cancel all at the same time. Okay, our next one, we have a product of 80, a sum of 18. What are my numbers?
10 and 8.
Good. So I have z plus 10 and z plus 8. Okay? My denominator, you might initially think, oh, I can't do anything with that, but I can. What can I take out? Z. Excellent. Okay. If it's on the top and on the bottom, we can cancel it. So I see a z plus 6 and z plus 6, a z plus 8 and a z plus 8, a z plus 3 and a z plus 3. Some students bring colored pencils to this test, and that's totally fine. You don't have to, but some do. Okay, so then I've got z plus 10 over z. I love the next one because everybody's like, oh, what happened? Okay, can I go to the next one? Okay, we are going to keep, we are going to change, and we are going to flip again. Okay, that's because of that division sign. We keep, we change, we flip. Okay, so I'm going to rewrite it first. I have x squared minus 16 over x squared minus x minus 20. My division sign becomes multiplication. I have x squared minus 25. X squared plus x minus 20. Okay, we're factoring. We got 4 different things to factor. I'm focusing on that first. What is that? What kind of polynomial is x squared minus 16? It's difference of perfect square. Okay, it's difference of perfect square, so it becomes x plus 4 and x minus 4. Excellent. Okay? X squared, so now I'm doing this one right here. X squared minus x minus 20. I have a product that's negative 20. And anytime I have a negative product, I'm going to have one positive and one negative. My sum is negative 1. So I have x plus something and x minus something.
X plus 5, x minus 4.
Good. Why is the 5 positive?
Because 5 minus 1 gives you, 5 minus 4 gives you 1.
Okay, and do I need a positive 1 or a negative 1?
Negative.
Good. So what should be positive and what should be negative?
4 should be positive, 5 should be negative.
Good. Okay, that's because we have a negative x right there. So it's plus 4 and minus 5. Because we've got to add those two numbers together and get something that's negative. Okay? Now, x squared minus 25, that's a difference of perfect squares. So I have x plus 5 and x minus 5. Okay? Now, I've got the same thing again. I've got a negative product, or not, it's not the same thing, it's something similar. But this time I've got a positive 1. A negative product, negative 20, and a positive 1. So what will that be?
X plus 5.
Good. X plus 5 and x minus 4. Good. Okay, if it's on the top and the bottom, we cancel it out. Okay? I have x plus 4 and x plus 4. X minus 4, x minus 4. X minus 5, x minus 5. X plus 5, x plus 5. And everything is gone. The number one wrong answer I get to this is 0. And that is the wrong answer. Okay? 0 is not the correct answer. But I see that a lot. A lot of people put 0 there because they've canceled everything out. So they think, oh, everything's gone, then I have 0 left. But think about what is 2 over 2. It's 1. Okay? So when I do that, or if I have 2 over 4, okay, 2 goes into 2 one time, 2 goes into 4 twice. So when something goes into it and it cancels out, we get 1. So the answer to this is positive 1. That's our answer. Okay? Now, on the back, we have 2 problems that look like this, and then we have 2 problems that have an equal sign. Okay? When no equal sign is present, when you're let me add to that. When you are adding or subtracting, and there's no equal sign. Okay? You are going to rewrite in terms of a common denominator. Okay? So when I rewrite this, I'm going to have a numerator and I'm going to have a denominator. I am rewriting it. That's the key word right there. I am rewriting it in terms of a common denominator. That is because I do not have an equal sign. I do not have an equal sign. That's going to be true for this one and this one. I do not have an equal sign. Okay? So, let's go ahead and do this. I need to find my LCD, and if I rewrite this, it may be a little easier to see. Okay, so I have x squared, which is x times y. Okay, so in my LCD, I've got to have an x, I've got to have another x, and I've got to have a y. Okay? Now, I wrote it out like this, and this is technically using prime factorization because in my denominator, I don't have any pluses or minuses. I'm not factoring a binomial or trinomial. That x squared times y is a monomial. I'm only multiplying, and so it's better if I write it out like this. Okay? Then my next one, I have 2, and then I've got x times y times y. Okay? Now, I've got this x covered, and I've got one of my y's covered, but what am I missing? I'm missing another y. Okay? So I need to account for this y right here. So do you see how in one denominator I've got x squared? So that means in my common denominator I have to have x squared. Then in my other denominator I have y squared. So that means in my common denominator I have to have y squared. Okay? Now, I'm going to look at each individual denominator. So in my common denominator, I've got x times x and y times y. In my first denominator, what am I missing?
Y.
Good. So if I'm missing it, I have to multiply the top and the bottom by it. Okay? What am I missing in my second fraction?
X.
Good. So if I'm missing it, I have to multiply my top and my bottom by it. So now I can rewrite this. My denominator is x squared times y squared. And then I have 7y plus 2x. Okay? Okay. We are going to use those same principles for the next problem because our next problem does not have an equal sign. When you're plus or you're minus and there's no equal sign, you rewrite it in terms of a common denominator. And I should say when you're adding or subtracting and there's no equal sign, rewrite in terms of a common denominator. So that's what we're going to do here as well. So we've got to determine our LCD. Before we can determine our LCD, what do we have to do with the first denominator? What do I need to do with that? I need to factor it. Okay, so I'm going to have x plus 5 and x minus 5. Okay? Now, my first denominator for my LCD, I'm going to go ahead and write down x plus 5 and x minus 5. Okay? My second denominator has x minus 5. Do I have to write that down again? I don't. Okay? Now, my first denominator has them both in it. So do I need to add anything to it? No, because they're both in it. My second denominator doesn't have 1. What does that one not have?
X plus 5.
Excellent. So if it doesn't have it, I have to do it on the top and the bottom. Okay? So my denominator here is x plus 5 and x minus 5. Okay, I have 8x. What am I doing with this x right here?
X squared plus 5x.
Good. I'm distributing it. So I end up with x squared plus 5x. And if you got this, you're super close. But what do you need to do? Excellent, excellent. 13x plus x squared. Many students would write it x squared plus 13x. I guess I'm going to write it that way.
Would you count off if we put 13 first?
Nope, I wouldn't count it off. As long as it's got an x with it. Yeah. Okay. So the key part of this right here is that it does not have an equal sign. That is when you have a numerator and a denominator in your answer, and you're going to have variables in your answer. Okay? When there's no equal sign. Actually, I'm going to add that right here. Variables will be part of your answer. And, you know, and I say that, and we did one time get the 1/1. So it is possible that they all cancel out. But in general, variables will be part of your answer. Okay? Now here, we have an equal sign. We have an equal sign. When you have an equal sign, you are still finding your LCD, but you multiply everything by your LCD to eliminate. That means get rid of. You are getting rid of. You want to eliminate the denominator. Okay? You still have to find the LCD, but you're multiplying everything by the LCD. Okay? Your answer will be something like x equals some value. Okay? You're finding a value for x. In these situations, you also have an undefined value. Okay? You also have an undefined value that you have to find. Okay? Okay, let's factor our denominators and then we'll get going on this. Okay? So, I've got 4 over y plus 4. I can't do anything with y plus 4. It's in simplest form. Do you see that minus sign? I'm going to put it in the numerator. So I'm going to make this plus -2. I want to go ahead and move that minus sign to the numerator. Then I have y minus 4 in the bottom. Okay? That equals 14 over y plus 4 times y minus 4. Okay? So, my undefined value, that's what I want to deal with. What can x not be? What can x not be?
4 or negative.
It can't be 4 or negative 4. Now, let's talk about how you got that. You cannot have 0 in the denominator. So, I'm going to take this denominator right here, and I'm going to say y plus 4 cannot be 0. Okay? So then I get y cannot be -4. I have just solved for y. I have solved for y. So an undefined value for this is -4. Now, I'm going to do the same thing with this one. Y minus 4 cannot be 0. Okay? So for this one, y cannot be 4. So y cannot be 4 or negative 4. And if I get 4 or negative 4, what do I have to do? Throw it out. Got to get rid of it. Okay. So I'm going to erase my undefined value part. Okay. What's my LCD? Okay. Here, I've got a y plus 4. So that's going to be part of my LCD. Okay. Here, I've got a y minus 4. That's going to be part of my LCD. Here, I've got a y plus 4 and a y minus 4. Is that already accounted for? Yes. So I don't need to do another one. Okay, so it's already accounted for. So what I'm going to do now is I am going to multiply everything, and this is when you get to find out if I write small enough. I'm going to multiply everything by y plus 4 times y minus 4 over 1. Because when I do that, I am eliminating my denominators, which is what I want to do. I want to eliminate them. Okay? So I'm going to have 4 over y plus 4 times y plus 4 times y minus 1. Okay? Then I have plus negative 2 over y minus 4 times y plus 4, y minus 4 over 1, and that equals 14 over y plus 4, y minus 4, and then I am multiplying that times y plus 4, y minus 4. Okay? Now I get rid of everything. Everything that shows up on the top and the bottom I can get rid of. So y plus 4 and y plus 4. So I am left with 4 times y minus 1. So I have 4 times y minus 1. Or no, that's y minus 4. Oh, yeah. Yeah. That's y minus 4 right there. Y plus 4, y minus 4. That's my LCD. Okay? Here I've got y minus 4 and y minus 4. That's not as pretty as I want it to be. Okay? So now I'm left with negative 2 times y plus 4. Students sometimes forget to distribute that negative 2, and that causes a problem. So be sure you distribute that negative 2. Then I've got y plus 4, y plus 4, y minus 4, y minus 4. Okay. Now, I have 4 times y minus 4 minus 2 times y plus 4 equals 14. What I am doing here to solve for this one, I get the y's on one side and I get a number on the other. That is because my y is raised to the first power. This is linear, so you're just solving it like the very first equations we ever solved. Okay? You set it equal to 0 when you've got your variable squared or to the third, or when it's raised to a power other than 1. Okay? So now I've got 4y minus 16 minus 2y minus 8. A lot of people made a mistake right there with the minus 8. Okay, they ended up with plus 8 or something like that. That equals 14. 4y and negative 2y give me positive 2y minus 24. All I did there was I combined like terms. 4y and negative 2y, negative 16 and negative 8. I combined like terms. Now I'm going to add 24 to both sides. One day I'm going to learn how to write small enough. Do you believe me? I wouldn't. So I have 2y equals 38. 2y equals 38. I divide both sides by 2, and I am left with y equals what? 19. Okay? Okay, the next problem is very, very similar. Very, very similar. So the first thing that we're going to do is we're going to factor any denominators that we need to factor. Okay? Is it okay if I go off the screen? Okay. Okay. So I'm going to rewrite this because I'm going to factor that denominator. So I have x over x minus 5. I'm going to make this plus, and I'm going to move the negative to the numerator. Okay? Then I'm going to factor x squared minus 25. That's x plus 5 and x minus 5. This is a good time to find my undefined values. My undefined values. This right here cannot equal what?
Zero.
It can't equal 0. X minus 5 cannot equal 0. We cannot have a 0 in the denominator. So this is x cannot be positive 5. So an undefined value is x cannot be positive 5. Okay? Here, what do? X plus 5. So what do I get for this one?
-5.
Good. So x cannot be 5 and x cannot be negative 5. Those are my undefined values. It's a good idea to think about your undefined values. If you don't do it first, definitely look at the end to make sure. Definitely make sure once you get your answers to see if they're undefined. Okay, now that I have my undefined values, I can find my LCD. Okay, I have my undefined values, so now I can find my LCD. My first rational has x minus 5. Okay, my second one has x plus 5. Okay, my third one has x plus 5. Do I already have that accounted for? Good. Then I've got x minus 5. Do I have that accounted for? So I don't need to do it again. Okay, now I'm going to multiply everything times my LCD. So it's x minus 5 times x plus 5 over 1. And I do that because I want to eliminate my denominators. I want to eliminate everything that's in the denominator. Okay. Whew. Let's see how little I can write. X, whoops, I don't want to do it in that color. I want to do it in this color. X over x minus 5 times x minus 5 times x plus 5 over 1 plus negative 5 over x plus 5 times x minus 5, x plus 5 over 1 equals 50 over x plus 5, x minus 5 times x minus 5, x plus 5 over 1. Okay. If it's in the top and the bottom, we can cancel it out. X minus 5 and x minus 5. I'm left with x times x plus 5. Okay? X plus 5 and x plus 5 cancel out. Some students lose that negative, and that makes a difference in your answer. If you got this wrong, it's probably because you lost your negative. Okay, and so I've got negative 5 times x minus 5, and that's going to equal 50. Okay, now I have x squared plus 5x minus 5x plus 25. I got a lot of people that made that negative 25. And that's because they forgot to distribute their negative. So be sure you're distributing the negative and you're distributing the 5. Okay? And that equals 50. Okay? That equals 50. My 5x, my minus 5x, they cancel. Okay? Then I'm going to subtract 50 from both sides. And a question that I sometimes get is, why do I set this equal to 0, but the one right before it, I didn't? Why? What's different about this one than the one right before it?
X squared.
Absolutely. You got it. Good job. It's x squared. So because it's x squared, anytime you've got it squared, you've got to set it equal to 0. So now I have x squared. What's 25 and negative 50? Excellent. And now I've set it equal to 0. Some of you have done it to where you end up with x squared plus 25, and then you take the square root of 25. And when you do that, you only get 5 as your answer. Okay? It's fine if you use that square root property, but don't forget to put the plus or minus in front of it, because plus or minus is your answer to this. Okay? Now, I'm going to factor this. X squared minus 25 factors to x plus 5, x minus 5 equals 0. X plus 5 equals 0, and x minus 5 equals 0. Okay, so x is negative 5, and x is 5. Now, sometimes we're just so glad to be done, we circle the answer. No, why? You're right, why? It's our undefined values. Okay, so what do we have to do with these? Throw them out. I mean, sometimes we just have to throw one out. This is a situation where we have to throw both of them out. So if we have to throw both of them out, I can't have either one as my answer. So what's my final answer here? No solution. No solution. It's a lot of work, right? Okay. The next one is division. I am going to do it both ways. I'm going to use synthetic division and I'm going to use long division. Okay? You are allowed to use the method of your choice. You are allowed to use the method of your choice. The issue with this particular problem is that we don't have an x squared. Okay? We've got an x to the third, and then we go straight to x to the first. So what we have to do is we've got to account for that. So I've got x to the third plus 0x squared. You've got to put that in there. Then I've got minus 7x minus 6. So I'm going to put this in the box, and x minus 3 goes outside the box. Okay? That's going to bug me. It needs to be written a little bit lower. Okay. Now you ask yourself, x times what gives you x to the third? X times what gives you x to the third?
No.
X squared. X times x squared gives you x to the third. Okay? X squared times negative 3 is negative 3x squared. X squared times x is x to the third. Now, we have to subtract these. And that's where students sometimes make their mistakes, because in synthetic division, we don't. So for here, we're subtracting. So you change the signs. My x to the thirds cancel, and I'm left with 3x squared minus 7x minus 6. Whoops. Actually, I didn't mean to do that. I just meant to do the minus 7. I do synthetic division all the time, so I have to refresh my memory on how to do this.
Okay, so how do we get to 3x?
Okay, do you see my 0x squared?
Yeah.
Okay, so I had to subtract negative 3x squared from that.
Okay.
So 0 minus negative becomes positive. That's how. Good question. Okay, now I'm going to ask myself, x times what gives me 3x squared? X times what gives me 3x squared? Okay, it's 3x, because x times 3x gives me 3x squared. 3x times negative 3 gives me minus 9x. 3x times x gives me 3x squared. Okay, I have to subtract. So I change the signs. Minus 3x squared plus 9x. So I'm left with 2x, and I bring my negative 6 down. X times 2 gives me 2x. 2 times negative 3 is negative 6. 2 times x is 2x. I am subtracting, and I'm left with 0. Does anyone want to do that using synthetic division? Yes,
Yeah.
I am with you. Okay, I need to erase this. Is that okay? Okay. The number one mistake students make is they forget to account for that x squared that has to have a 0 in it. Okay? So again, you need to remember that this is really x to the third plus 0x squared minus 7x minus 6. Okay? You've got to remember that. Now, when I write down the number that I put in my box is the solution that's associated with that factor. And the way that I get that is I say x minus 3 equals 0. X is what? What does x equal?
Negative 3.
It equals positive 3 because I add 3 to both sides. Okay, so that's something that students get confused on right there. That's what I put in my box. I put the solution in my box. I do not put the factor. I put the solution. Then I bring down just my coefficients. I don't do anything else. I just have my coefficients. Okay? My first step is I bring 1 straight down. Then I multiply this 1 times what I have in my box. That's what I multiply it by. 1 times 3 is 3. I combine these and get 3. I multiply this 3 times 3 because that's what I've got in my box. 3 times 3 is 9. I combine those, get 2. 2 times 3 is 6. And I get 0. That 0 means I do not have a remainder. Okay, so this is my remainder. Okay, this is my constant. This is my x, and this is my x squared. So my final answer to this is 1x squared, 3x plus 2. That's my final answer. And is that the same thing I got here? Nope, that's not it. Sorry. But it's the same thing when we did long division. Okay? What's the best thing that you can do to study? Practice test. Okay, when are my office hours tomorrow? 8 a.m. 8 to 9:30. 8 to 9:30. Okay? I will see you guys on Friday.